All right, guys, we're going to go ahead and go over our CFA from 7.1 to lesson 7.3. Again, you've got your hard copies there, so listen to the reteaching here and having these ready so you can study for your test. So on the first question here, 6 more than y is less than a half of 20. Okay, there's our situation, and we're supposed to write this inequality to represent the situation. Okay, so 6 more than y. So we know more than means add, so 6 more than y, 6 plus y, is less than, so all right, my less than symbol, 1/2 of 20, and we know of means multiply, so 1/2 of 20. All right, so there's our little more advanced inequality we've written here, and our job is, if y is greater than 0, so they put the constraint on it there for me. If the y is greater than 0, graph the solution set. So graph all the answers for y on this number line below. Okay, so I'm going to simplify this a little bit to make it simpler. So I could change that to 6 plus y is less than, and I know 1/2 of 20 is 10. Okay, so that's going to make it a little simpler. I could probably use some trial and error from here. A lot of you would be able to do, because we know 6 plus 4 is 10. So if I plug 4 in here, 6 plus 4 is less than 10. I know that doesn't work. It's exactly equal to 10, but anything less than that could work. So if I plugged in a 3, 6 plus 3 is 9. That's less than 10, and so on and so forth. I could also check in, though, or put in like 3.5 or 3.6. Don't forget those decimals. So I should know that in this case that y is going to be less than 4. Okay, so I could go down, I'll write it up here. I know y has to be less than 4 to make this true, and I could do that with some trial and error. Okay, now I also know there's some ways we can handle this like an equation. I want to isolate the variable, so if I add 6 to y to undo that, thinking of that pan balance type set, if I take away 6 from one side, I must take away 6 from the other side. So this just becomes nothing but y, and then 10 minus 6 is 4. So again, y has to be less than 4. So you can do that by isolating the variable as well, or you could use trial and error there. And we've got the constraint here, if y is greater than 0, so I know it has to be greater than 0, so I can put an open circle on the 0 there, and I know it's got to be greater than that, but at the same time, I know y has to be less than 4. So again, open circle on the 4, because it can't equal exactly 4, it has to be less than that. And then I could shade anything in between there, any number, decimal, there's infinite answers in there, but it has to be somewhere between 0 and 4 to make this true. So what are 3 possible values? I could choose whole numbers, 1, 2, and 3 would work, but I could have used 1.5, 2.5, 3.8, anything between there, the answers are infinite, okay? So make sure you're getting this written down. You can pause the video if you're watching it on your own, or if you're watching it at home, to make sure you have this written down. And then I'll scroll up and we'll start talking about number 2 here. Okay. All right, so number 2 here. Go ahead and take a quick look here. It talks about we're going to use variables and an inequality to find out what you could buy for lunch here. Okay, in this situation, you have at most $14 to spend on your lunch. You want to get a sandwich and a few side dishes, and the sandwich is $8.50, and each side dish is $2. So we need to define a variable. Okay, what's missing here? What's the unknown? In this case, it's the number of side dishes we can afford, because we know we only have $14, and I already know what the sandwich costs. So I'm going to just say, let's say D stand for the price or the number of side dishes. I already know the price, so D would be the number of side dishes that I want to buy, okay, or that I can afford in this case. So the inequality, I know that means like greater than or less than. It's things that aren't equal. To represent this, well, I know the sandwich is $8.50 plus the side dishes I can afford. Well, I know each side dish costs $2, so it would be $2. Okay, and I'll use my decimal there. $2 times each side dish, and I called that the number of side dishes. We just called D. So I'd have to take $2 times each side dish and then add that to the $8.50, and that has to be less than or equal to $14, because I only have $14. Okay, so there's the inequality. The sandwich plus the side dishes, $2 times each side dish, has to be less than or equal to $14 because I don't have $14, or I only have $14. So how could we use this to solve? Well, this is kind of going to need to use those inverse operations and try and undo some things here. So for example, if I know the sandwich is $8.50, I can take away that $8.50. So that means that's going to cost $8.50. So I'm going to take away the $8.50 from the other side. So what I'm going to be left with here is $2 times each side dish has to be less than or equal to, and if I subtract 14 minus 8.50, you'll get $5.50. Okay, so that has to be less than $5.50 when you subtract these. So again, to isolate that variable, or you can kind of use your common sense here and do some trial and error, but if I do 2 side dishes, that costs $4. But if I do 3, $2 times 3, that's $6. That's too much, so I can only afford 2 of them. But if you want to find out exactly, remember to isolate a variable. If I multiply by $2, I have to divide by $2 to undo that. So I need to divide by 2 here. I can just say 2 since. Okay, and that would leave me with D, or the number of side dishes, has to be less than or equal to, and then if I cut that in half, you get $2, 2.75, or side dishes. So really, you can afford 2.75 side dishes, but you can't buy 0.75 a side dish. So how many can you buy? You can buy 2 side dishes, and then you'd get a little bit of money back, a little change back there. Okay. So again, that's using an inequality, using your algebra here to solve, a real life problem. All right. So pause it if you need to. We'll flip over and look at the last part here in a second. Shrink this up a little bit here. All right, so let's take a look here. We're looking at this spreadsheet here. Okay, should be able to see it now. All right. So we've got an item name and a unit price. They've got them labeled here, the quantity I want to buy and the total. So I can see here that we're taking the price times the quantity. So I should be multiplying these 2 things to get my total, and we want the program, the spreadsheet, to do that for us. So the question A talks about what formula will you enter in D4, which would be right here. D4. To get that to do $2.38 to do the math for you, I need to program it to take this cell times this cell. Remember, when you do this, guys, you have to start with an equal sign, and I just highlight this and put an equal sign here, and then it would start to calculate for me. That tells it to calculate the formula. It tells you what to equal. So I would say whatever in B4, and I want to take that times C4. So B4 times C4, and if I do that, that's going to automatically take this cell, B4, and take it times C4. So it'll take $1.19 times 2 and automatically calculate that's $2.38. And I've told it what to do. It'll do it by itself, so I don't have to figure it. Okay? And then the last part, what formula will you enter in cell D10, which is D10 is clear down here. And to get the total, I know that's the total, I would need to add these 2 columns. So I could take D8, got to say equals first, D8 plus D9. D8 plus D9, that would add this column plus this, and that's the total plus the tax to get that overall total. Okay? So again, making sure you get these written down, and if you have questions, let me know, and we'll talk through some more about this.